Good afternoon, learners of grade 7. I'm MJ Matlala. I'm going to take you through the properties of materials. So before we can address the physical properties of materials, we need also to define matter and its three states. And we also need to emphasize what are the materials and their properties. How can we measure the strength of materials? What does it mean when a liquid boils? How can we explain the term boiling point? How can we explain the term melting point? Now, matter is anything that occupies space and has mass, which means you must have mass, it must have mass, it must also have a volume. Around us, we have the following three stages of matter, which is solid, liquid, and gases. Now let's look at solids. Solids keep its shape, which means it is a hard substance. It keeps its shape. Liquids flow and take the shape of the container. Gases, such as air, tend to spread out with no define, but it can be held by its container. Now let us explore what are materials. A material is a physical substance used to make things. We have metals, we have plastic, ceramic, glass, fiber are some of the main categories of materials. So in life, we only talk about fiber, but now you will realize there are other materials as well. If you can look at the first slide also indicates that we have three stages of matter. Why? Because water is also a material. You will see when we discuss the boiling point. For example, clothes wiring are made from fiber. Chairs which we sit on are made of plastic. Some are also made of wood. Windows in the schools are made of glasses. Can you see any other example around you? Maybe if you're in a class, you can see a lot of examples of materials. But remember, our topic is the properties of material. Therefore, we also need to define what is property. A property of a material is a description of the characteristics which it has. They are adjectives, which means they explain the noun, which tells us about the material. Materials have different properties and characteristics depend on what we use them for. Some materials are hard, others are soft, some are strong, others are weak. Now here's a list of the properties of materials which we always come across. Some materials shine, some are strong, some are flexible, some are light, others are heavy, others we determine them by their colors, others can attract magnets, others can bend like a ruler, for example. Some are hard. When we talk about something which is hard, is something which you cannot bend easily. Some are brittle, it is hard, but it will break easily. We can take an example of a ceramic. Some are malleable, it can be shaped. In most instances, you will find them in the group of matter. Some can bend, some are transparent, some can even conduct electricity. If I have time, I could have demonstrated how you can connect a wire or a teaspoon to a bulb and a cell. It will conduct electricity. Some are insulators, which means they don't allow electricity to pass through. Let us explore two different questions here. Which of the previous words could you use to describe a pencil? Is it hard? Is it light? A window, is it transparent? Is it translucent? Is it hard? Is it brittle? A piece of paper, is it light? Is it malleable? A fork, does it shine? Hard? Magnetic? Or can it conduct electricity? Now here, materials can be categorized into a main group, which is metals. So metals are strong. That's one of the things that you must know. Metals shine. Metals can conduct electricity and heat. Some metals are magnetic. For example, if you can take copper or a plier, you will see that it is attracted by a magnet. These properties make are suitable for making things like bridges. We know that we need metals, we need strong things to build bridges, to make tools, coins, knives, and forks. Can you think of any other use of metals? Right, let us see. Maybe I have a few here for you, grade 7 learners. Some of our metals can conduct electricity, and secondly, they are very strong, which means they are suitable for electrical wiring. So we know their properties. They can conduct electricity, which means electrons can pass through it. Why are saucepans made of metals? Let us look, why are they made of metals? The first thing, they are good conductors of heat. It does not melt with high temperature, and they are strong. Now let us go back to the first slide. What are the three states of matter? The first one, you know that it is a solid. The second one is a liquid and a gas. We can also define these states. Let's look at the first state, solid. A solid has a defined shape and volume, which means all solids have shape and volume. let's view at their particles. All their particles, you will see that they are closely packed, which means the particles of solids are just vibrating. So because if you look at the atomic model, all particles are in constant moving. So what happened? They are just vibrating because they are close to one another. Right, let us look at liquids. A liquid has a defined volume, but it has no defined shape. It takes the shape of the container. If you look at my presentation, you can see that actually there's a liquid which is being measured, and it is 100 millimeters. Now let us look at gases. Gas do not have a defined shape or volume. We have an example there, bromine gas. It fills up the entire volume of the container. There are two demonstrations there, you can look at them. Now, in science always we demonstrate how particles are moving. Particles can move freely and will either fill up or squeeze into the available shape, which means you can squeeze gas particles. Or if you expand the space, it will also fill up that space. Now, here is also just a demonstration of the three phases of matter. We have solids. We can see they are very closely packed. We have liquid. Actually, they are moving around. And gases are far up. The particles of gases are far apart. Now let us go to the melting point. You will remember when I've started, I've talked about materials, and I've included the three phases of matter. The main reason was to look at the properties of some of the materials, like for example, water. Now the first thing that you need to know is what is melting. Melting is the change from solid to liquid, which means the state of solid, where a solid will change to liquid. Let's take for example, you have an ice. If you heat it up, it will change to a liquid. Now, what is the melting point, which is very key for us today, is a specific temperature when melting occurs. Each pure substance has a specific melting point. For example, water is 0 degrees Celsius. Nitrogen, because it's in the form of a gas, is very low, is 209.9 degrees Celsius. We have silver, because it's always found in a solid state, it is 961.93 Celsius. Carbon, it is 3,500 degrees Celsius. This is the melting points of these materials. Can you see even gases can be classified as materials? Now there's just a slight demonstration of the melting point. Right, if you increase thermal energy, a solid will change from liquid, from solid to liquid, which means that at a fixed point it will start to change. For example, at 0 degrees Celsius, water ice will change from a solid state to a liquid state. Now let's look at another state before we can talk about the boiling point. We have vaporization. Evaporation is the state where liquid turns to gas. Evaporation happens when particles in a liquid gain energy to form a gas. We have two types. The first one is evaporation. This evaporation takes place when a liquid turns to gas on the surface of a liquid. But boiling takes place when the gas below, when liquid changes from liquid to a gas at the surface of your liquid, which means it needs energy to do that. Now the boiling point is the temperature at which water, nitrogen, silver, or carbon turns from a liquid to a gas. Each of the following substances has specific boiling points. You can see for water we have 100 degrees Celsius. Nitrogen is minus 195.79 degrees Celsius. Silver is 2162. You can see it is quite high. Right? This is just a demonstration where you can see that solid can change from solid to liquid, or it can even changes. There are materials where solids can actually change from a solid to a gas. And that is known as sublimation. And deposition is when a gas changes from a gas to a solid. Then we have evaporation, which I've already explained. And then, now let us look at the graphical representation of the melting point and the boiling point. So the first thing is that when you talked about your boiling point or your melting point, temperature is involved. Let's say you have an ice tube of water and you want to change it to a liquid form. You need to increase its temperature. Let's say it is at 100 degrees Celsius, and when you increase it, when it reaches 0, it is at that point where the solid will change to a liquid. And again, if you increase the temperature again, what will happen? The liquid will turn to gas at 100 degrees Celsius. Now let's investigate. Right, as I've said, I'm not going to demonstrate. Let's say you are having 3 kinds of papers. That is a cardboard, and you have as well dates. And you want to measure their strength. So the first thing that you are going to do, you can start with one nail and see whether can it really hold this plastic. Yes, the first one can hold, this cardboard can hold it. Let's take the second one. The cardboard can still hold it. Let's take the third one. The cardboard can still hold it. Even if we have 5 nails, it's possible it can hold it. Now let's take a tissue, for example. I'm sure you are seeing me on the camera. I have a tissue here. I want to see whether can this tissue hold 1 nail. Right? I'm pouring it. Yes, it can hold 1 nail. Let us look at the second one. Just a minute. It breaks when you use the second nail, which means the tissue can only hold 1 nail. Now let us take a photostat paper. Yes, it can hold 2 nails. Let me add another nail and see whether can it hold 3 nails. Yes, it can hold 3 nails. Let me take 5 nails. Yes, it can. And maybe we must increase the number of nails. Let's take 10 nails. Because the tissue is out, it can only hold 1 nail. I'm going to use now extra 5 nails to see what will happen. Yes, I'm adding the 6th one. Let us see. The 7th one. Let us see. The 8th one. The 10th one. It can still hold it. The 11th one. I still have a lot of nails here. 12, it still holds this nail. 13, it's still. 14, it's still. 17, it's still. 18, 19, which means still adding a lot of nails here. Let me just see. A photostat paper is very strong, like a cardboard, but a cardboard is stronger than a photostat paper. Yes, I don't have enough nails. I could have demonstrated to you that at a certain point it is going to break. So even similar materials don't have the same properties. Now you can make this, you can complete this exercise taking a cardboard and throwing in nails. You will see at a certain point the paper is going to break, which means a paper can hold a certain weight. But as you have seen, a toilet paper can only hold one nail. But a photostat paper, let us go to a newspaper and check what can it do. I first have to count them. Let me throw them out. I'm starting with 5. 5 nails. A newspaper can hold 5 nails. Let me increase the number. We're having 6. It can still hold 6 nails. We have 7. It can still hold 7 nails. Let's take 8. It can still hold it. Let's take 9. Still 10. Still 11. 12. 12, you can still hold 12, 13, you can still hold 12, 13, 14, can still, 15, let's look at 15, yes, 16 years, but it can't hold 17. So which means the strongest paper that we have is a cardboard, then is a cardboard, and the second one, if we have to list it, is a photocopy paper, and then we have a newspaper is weaker than. Let us just answer some of the question. Which paper is the strongest? The first one, the strongest one is a cardboard. Which is the weakest one? According to our demonstration, it's a tissue. Now we can even arrange these papers in the order of their strength. The first one will be a cardboard. Then we have a photocopy paper. Then we have a newspaper. And lastly, we have a toilet paper. So, grade 7 learners, this is one of the activities that your teachers can give you. It is actually an investigation, because you have to start by writing a hypothesis where you state in advance which paper will be the strongest. And I thank you for today, and I hope you have learned something. If there's any questions, please feel free to ask. But if there's none, I thank you.